Number 9.
Circle.
Oh, the other thing too. It's down at the end of the year. I don't answer my phone at home over the summer, so when the parents and people try to call me and complain, why didn't you tell me my kid was failing? I'm just to that point, Gretchen, about where you're at probably, where it's just like, you know what? I'm tired of complaining at Johnny and Sally about, hey, you gotta do the work, you gotta do the work, you gotta pay attention. At some point, it's gotta be on you guys, right? I can complain, I can call mommy and daddy, and now I'm just over all that. It's time for somebody to step up and say, you know what, I really don't wanna fail this class because I wanna see Ebersole again. Let's do some work. Number 9. They give us a circle. What's it got? It's got like a little crazy thing in it.
Triangles.
Bow tie looking thing or something. Is that A? Is that right?
Yeah, and that's D.
D?
Yeah. C.
D.
Ha!
And what do they tell us about this angle?
5x minus 1.
Thank you. How about this angle?
2y plus 1.
Plus 1?
Yeah.
This angle?
3y minus 20.
Thank you.
On 1 hand.
That's a 20. You can't hardly read
No,
it.
it's the C.
Oh, that's C?
Yeah.
Oh, my fault. What's this one? And I'll just mark them backwards.
4x plus 17.
4x plus 17?
Yeah.
These two are supposed to be switched around. Are we gonna be able to understand that? So I don't have to try to erase it and do all that crap.
Sure.
If we pick this angle, does everybody see angle DAC?
Yeah.
It cuts off what arc? DC. All right. What other angle cuts off arc DC?
BDC.
Close.
Or
D, B, C.
DBC. It's this angle, right? Cuts off that arc. So what has to be true about that angle and this angle? They have to be congruent. One of them is 5x minus 1. The other one, even though I messed it up, is supposed to be what?
4x
4x plus 17. How do we solve that?
Yeah, minus
plus 1,
4.
or, yeah, minus 4.
Minus 4x on both sides. Always get the x's together first, makes it easier. We got x minus 1 equals what?
17.
Then you plus the 1. 18.
X equals 18. Just looking at that, what do you think is going to be true about this angle and this angle? They're congruent. So 2y plus 1 should equal what?
3, no.
You're right.
3, 5 minus 1.
How do we solve that?
Minus 2.
Minus 2y on both sides. You end up with 1 equals, what's 3y minus 2y?
1.
Minus 20, then what?
Yeah, plus 20.
Add 20 to both sides, good. What's y equal? 21. Now go back to the problem, what they ask us to find. This is number 9, right? I think we're gonna do 9 and 10 together, because they're basically the same thing. What number 9 asks us to find?
Measure angle C.
Measure angle C. Angle C was right here. And it was supposed to be the 3y minus 20, right? So how are we gonna find angle C?
5x.
Plug in what for y?
21.
21. So 3 times 21 minus 20, is that right? Somebody do that, grab your calculator and do that. What's 3 times 21 minus 20?
43.
What is it?
43.
43?
Yeah.
14.
43? Number 10, let's just do number 10. It said find the measure of angle A. How are we going to find measure of angle A?
Yep. I'll plug in 18.
Plug in 18, so 5 times 18 minus 1. What's that give us?
89.
89. Everybody agree with that?
Yep.
Remember, anytime you have, what kind of angle is this? If the vertex is on the circle?
Inscribed.
Inscribed. Vertex is at the center of the circle. What's it called?
Center.
Central.
Central.
Alright, so anytime you have an inscribed angle and another inscribed angle, and they cut off the same arc, then they have to be the same. Other questions on 597?
Number 3.
Number 3. Somebody help me out with some letters here. What's this letter? Q. This letter? E. What is it? E. E.
Yeah.
R.
Yeah.
Then I think there's another letter up here in it.
S.
And they want us to find
QR.
measure of arc QSR, is that right?
Yeah.
And they tell us that this angle is 113 degrees. What kind of angle is that angle again?
Inscribed.
Inscribed, because its vertex is on the circle. What do you know about an inscribed angle and the arc that it cuts off?
The arc is double the angle.
Alright, so the arc's double the angle, or the angle is half the arc,
It's
whichever way.
226.
So this whole thing would have to be 226 from Q all the way around to R there, has to be 226. Arc QSR, well that's what we just found, wasn't it? QSR, that's what we just found, so what's the answer? 226 degrees.
Can we go for
24. I think 24 is sort of a stupid, oh no, 24 is alright. It was 21 and 22 that was a dumb problem. They gave you stuff and then you didn't have to really do anything. Does that look about right?
That was a good.
What's this?
X.
This?
W.
This one?
Z. Y.
Now, they tell us some stuff. Tell me what they tell us. How about
2y minus 7.
2y minus 7?
Yeah.
How about W down here?
X plus 18.
Plus 18?
Yeah.
It's 3y minus. Yeah.
It's 3.
That's it.
3y minus 7. What's y?
2x.
Just 2x?
Yeah.
Z?
3y plus 1.
3y plus 1?
Yeah.
Is everything correct? We said if quadrilateral is inscribed in a circle, we had a theorem that said what has to be true about these opposite angles.
Perpendicular. No?
That's what everybody guesses, so make sure you get this right now, Sean, so make sure you don't think congruent. They're not congruent to each other. They add up to
Oh.
180. They add up to 180, alright? So if that quadrilateral is inscribed in that circle, those two angles have to add up to 180. So for y here, what equation can I set up?
3y minus 7 plus 3y plus 1 equals 1.
Write that down on your paper there and start to solve it, what's the other equation I can set up for these two?
2x plus a
2x plus, sorry, got in the way.
x plus 18.
Has to equal what?
180.
Somebody solved the top one, a few of you solved the top one, a few of you solved the bottom one.
First one is 31.
Y is what? 31. Anybody else get that for Y?
Yep.
About X, anybody get X yet?
$54.
54. Now the bad thing is that's not our answers, what they ask us to find on 24.
X.
Did 24 just ask us to find X?
Measurement of angle X.
Oh, angle X. So we want to find the measurement of that angle, how are you gonna do that? So we're gonna plug in Y right there, so it's gonna be 3,
times 31 minus 7.
do that on your calculator, 3 times 31 minus 7.
86.
Say it one more time.
86.
86 degrees. Let's go ahead and do 25 too, I think it's, or is it 23? 23. What's 23 ask us to find?
Find measurement of angle W.
How can we do that?
3. Oh, wait, no, not 3. 54 plus
54 plus 18, what's that?
18. 72.
Is that right, 72?
Yeah, it is.
Yeah.
Alright, just real quick, some of the rules that we've covered so far. You got a central angle. What do you know about the angle and the arc?
We're the same.
They're the same. You got an inscribed angle. What do you know about the angle and the arc?
The arc is double the angle.
So this has to be twice 2 times the angle. The arc is 2 times the angle, or the angle is half whatever the arc is. And then what we just got done covering there, if you have a quadrilateral 4-sided figure inscribed in a circle, what has to be true about opposite angles?
They add up to 180.
They have to be supplementary, they have to add up to 180. So those are some of the rules that we've covered already. What has to be true about these 2 segments? What's this called? What's this segment called for a circle? Radius. What's this one called? Radius. What has to be true about them?
It's tied.
They're always equal, right?
Oh, yeah.
What's this segment called for a circle?
Diameter.
Diameter. How's a diameter relate to a radius?
It's double.
Diameter is double the radius, radius is half the diameter, so on and so on and so on. You didn't grab the notes up there, go grab them. Fill in what you need to fill in on this. Just decide.
I thought that it'd be better to be in the back.
secant? What's the secant do in the circle again?
It goes through
Edge.
Goes through the circle. How many times does it touch the circle?
2 lines.
2 points every time. Tangent, what's the tangent do?
It touches the edge of the circle, but it's not.
So it just stays on the outside, on the edge of the circle. And that's called the point of tangency again.
Yeah.
So I just put those back on there. You got a tangent line, you got a secant line, because we're gonna use them again, and we've already talked about everything that we're gonna do today. We've talked about it before, but we're gonna go back over it, same as we've been doing this whole chapter, because I scrunched it all in before that test. So secant goes through the circle, touches it, 2 points. Tangent always touches it at exactly 1 point. This one we've written down like 16 times in the last few days, right?
Just about.
What's that angle called again? If the point's at this, or if the vertex is this at the center? Central angle. What do you know about that angle in that arc?
The arc is double the. No, they're the same.
They're the same, alright? So central angles, you just gotta keep this straight in your head. And at the end of these notes, there's something that will help you look back. If the vertex is at the center, the arc and the angle have to be the same. What do you think's on the next slide if we did central angle here?
Inscribed.
Inscribed angle. Probably looking at those cheap ones. Using our intelligence. So where's the vertex for an inscribed angle?
The vertex? Wait, what now? Oh, it's on the it's on the circle.
It's on the circle. If the vertex is on the circle, and we're gonna talk about some other angles that have the vertex on the circle, and the rule for them, same as this. The vertex is on the circle, then the arc has to be double the angle, or the angle is half of whatever the arc is. So if I told you this angle right here was 30 degrees,
That one's 60.
what's the arc?
60.
60 degrees. Don't make it harder than it is. Just remember, vertex has to be on the circle. So those we've already covered, just put them back on here just to go back over them. They're not going to go away. Next ones. A chord angle or a secant angle. Same angle, just depends on if you extend the lines on out or if you just cut it off at the edge of the circle. Notice, is the vertex of these angles at the center of the circle?
They're just.
It's just some vertex that's inside the circle, not at the center. So the vertex is inside the circle, not at the center. What do you know about these two angles? This angle and this angle. They're always equal. What kind of angles are they? They're vertical angles, good. They're vertical angles, so they have to be congruent. So we know the two angles. It doesn't matter which one of them we're trying to find, they have to be congruent. What has to be true about these two angles? This one and this one. They add up to 180. How about these two on the bottom down here? They add up to 180, so on and so on. So we know all that already. That's stuff that we've learned already. If I erase all this, the formula for this is the angle, and it just says angle. It doesn't matter which one. We're either talking about angle 1 or angle 2 here, whichever one. We know they're the same. To find that angle, those two angles cut off two arcs. And all you do is you take those two arcs, add them together. So add arc 1 plus arc 2, and you divide the answer by 2. So if I told you arc 1 out here was 40, arc 2 over here was 30, we just plug in there, it's 40 plus 30 divided by 2. What's 40 plus 30? 70. Take half of that. 35. So what's the measure of angle 1 right here? 35. What's the measure of angle 2? 35. Could we find this angle? Would you just tell me about angle 1 and that angle? It's 145. You subtract it from 180. What's the measure of this bottom angle down here? 145. Now, you got to be careful with this. Does that mean this arc out here is 145? No, it would if the vertex was at the center, but not in this case. It doesn't work. So you add the two angles, divide by 2 if the vertex is in the circle, but not at the center point. If the vertex is on the circle, we already did this. What kind of angle has its vertex on the circle? What kind of angle is this second one here? It's an inscribed angle. So we've already sort of done this, but there's another kind of angle that has its vertex on the circle where it looks like this. Instead of going through the circle, it sort of goes outside the circle. But the formula is the same. The arc is double the angle, or the angle is half whatever the arc is. Now this one could be a little harder. What if I told you this arc right here was 260 degrees? And we wanted to find that angle.
To add up to 360.
The whole circle adds up to how much?
360.
360. So could we find this arc right here?
Yeah.
How much is it? 100. And if that arc is 100, how much is that angle? 50 degrees. It's half of that. Kendall, you still with us? 'Cause now we're to the hard stuff. Kaylee, can you see?
No.
Do what?
This is not here.
If the vertex of the angle that you're dealing with is outside the circle. So we got vertex at the center point, vertex on the circle, vertex inside the circle, not at the center, and now vertex outside the circle. This one's a little tougher. It cuts off 2 arcs. Every one of these angles cuts off 2 arcs. And you have to subtract the 2 arcs and divide by 2 to get the angle. You're always going to subtract this outside arc, the one that's the farthest away from the angle, minus the other one. Because the outside one here, the one farthest away from the angle, is always going to be the biggest, and we always want to end up with a positive number. Think you can handle all that, Clifton?
Yeah.
This stuff pretty easy.
I was right.
We said that. You asked us, and then you didn't listen for the answer.
Wait, what are you talking about?
You said, is our assignment on page 611? And we said yes.
You said yes, I wasn't listening. No, it was before class.
Would you look at that?
No, I was just guessing.
Last thing here,
Clumsy.
little cheat sheet so that Hannah, when she's doing this stuff, when she's dealing with all these different angles, if this chart just tells you where's the vertex of the angle located, what's the formula to find the angle? So if it's at the center, the angle and the arc are equal. If it's on the circle, the angle equals the arc divided by 2. If it's outside the circle, and I'm not sure why I switched outside and inside, but is that going to
It's fine.
confuse everybody? If it's outside the circle, you subtract the 2 arcs and divide by 2. If it's inside the circle, you add the 2 arcs and divide by 2.
Oh my goodness.
Once you get that written down, open up your books, page 611.
What is today?
For what? For what?
What'd I say?
You said the 10th, it's the 4th.
I'm not sure how we want to do this because Keith's not here today to do all the work for you guys.
Yeah. I don't know if he could do it for himself. I wouldn't trust him with my work.
Probably shouldn't have recorded that, should
Oh, shoot. What? Who said that?
Kendall.
Thank you, Kylie. I appreciate that. That's the nicest, see, that's the nicest thing you've done for me for a while. I appreciate it.
See, who did that? Mr.
Kylie.
Ebersole.
On the assignment. I'm not sure, I'm trying to decide what we want to do here. No,
What? She always throws away my water bottles for me.
You're short. You need to be as close to the desk as
No
possible.
way,
Piece of
bro.
candy, don't
I'm
you?
gonna hit you with this. Do it.
what should we do? We should probably just say it's due at the end of class, shouldn't we?
No.
What? What'd you
Well,
say?
I mean,
Do it at the end of class.
No.
Put you
No.
no leg ready. Let's go.
Unless you'd like me to use the back of the book.
I do that to everyone.
Get it, 'cause-
How about